All right, section 11, we're going to be looking at logarithmic functions. You might have heard log. You might have dealt with logs a lot in high school. And we're going to see this little picture here is referencing a logarithmic rule. If you know it, then you might get the joke. If not, let's go ahead and take a look at those rules so we can understand the joke. So, for logarithmic functions, they're the inverse of exponential functions. Now, for example, if you guys remember, addition is an inverse operation of subtraction, right? Addition undoes subtraction the same way subtraction undoes addition. You add 3, you subtract 3, you get back to where you're at. Same thing with multiplication and division. Multiply by 3, divided by 3, you're back where you started. Well, logarithmic equations or functions are the inverse of exponential functions. So when something increases exponentially, right? To undo that, you take the logarithm and you're back where you started. And as you can see here, let's choose a blue pen for this one. Log base a of x equals y. That's the inverse of x equals a to the y. This is an exponential over here. And that's like what is it? It's a rough definition, and it's just a little thing to understand, or a note to understand why it is we're looking at these. All right, these are related with exponential functions. So for this lesson, we're going to be looking at a lot of rules, just things to keep out on the look for. And with these rules, I don't really have too many problems. I do have some examples, but we'll just mostly be looking at the rules and how to solve equations using those rules. So when the base is 10, notice how up here in the green box, this a here, that down there is the base. There's a base a. When the base is 10, there's no need to write it. We just put log x, right? There is an invisible 10 right there technically, but we don't write it because that's what we call base 10. So it's just log x equals y instead of log base 10x equals y. Now, what are the rules? The rules are as follows. There's a product, quotient, power, change of base, equality. This lesson looks a lot like the exponential rules lesson, where it's just a bunch of rules and you start memorizing them as you work problems out. It's really hard to memorize just looking at them and just trying to stamp them on your brain. There's another rule that isn't included here, and it's called the exponential log. With that said, just like the exponential rules lesson, I'm just going to show you examples of how these work. So first things first is the product rule. If we have log base 2 of 2x, we can split that, right? We can split it into addition. So addition and multiplication are related when it comes to logs, right? You can expand with addition. What happens is log base 2 stays. Now we expand it, and the 2 and the x get separated. So that's expanding. Quotient rule, same thing, but now it's with subtraction. For dividing 4 over x, we can separate those. Do log base 3 of 4 minus log base 3 of x. And again, that's coming from our quotient rule. Here's where the power rule comes. The power rule is the rule we used for the little illustration at the beginning with the emoji. If we have an exponent, we can bring it down as a coefficient. Right, so that's how that was with the sweat. We moved it to the front, it was a coefficient at the beginning. Next one is the change of base. Sorry, I may have skipped one here. Oh, yes, I did skip one. We're going to go change of base after this. Equality rule. So now we're looking at this rule here. Equality rule. If you have the same base, log base 6 in this case, log base 6, and they're equal to each other, then x has to equal 3. Right? So if you have two things equal to each other with logs and same base, then the two have to equal each other, the two arguments. Now we go to the change of base. Sorry, I went out of order there. Change of base, there's not much to say other than we have 4 here as a base, 5 as the argument. We can put them in a fraction as long as the bases match. That one isn't used too much when it comes to solving equations, but we might have to use it on a rare occasion. The last one is an exponential log rule. And that one we just have 10 to the power of log of whatever it is, in this case 3, should equal just that, 3. Right, so up here these x's match, so then these 3's match. And that's when we have 10 to the power of log, and then with our argument. So again, this is just rules we're looking at, not much to do here. We'll work out maybe 1 or 2 problems in the next slide. First things first, looking at the number e. If you've ever seen e as a number, that is an irrational number, just like pi, right? There's a symbol. But e is what we call, well, before I even say it, this is a famous mathematician right here. I'm underlining it. You might be tempted to pronounce it Euler. The proper pronunciation for it is Euler. Why? Don't ask me. That's his name. That's the mathematician's name. That's how you pronounce it, Euler. And E is known as Eulers Number because he made some pretty magnificent discoveries involving that number E. Now, it's not an E for Euler. The reason it's an E is because we use it a lot for exponential functions. So that's why it's an E. E to the x. Anyway, just keep in mind that E is just a number, an irrational number, just like pi. Don't think of it as a letter or variable. It is that irrational number, which is equal to 2.71, so on and so forth. It goes on to have infinite decimals. Anyway, the reason this is so important is because when a logarithm has a base e, we no longer write log, we write ln. And I'm sure you've seen this before, ln x. We write that instead of log base e of x. It's a little shortcut there. So that's the ln x. And I'm going to put some properties up here. These are really just the rules we went over last slide. There's a product rule, quotient rule, power rule. Here in this case, rule number 4, ln and e are inverse, so they pretty much cancel out, which is why we're left with x equals x. Same thing over here, e and ln inverse of each other, so we're left with x equals x. And then just one thing to keep in mind is ln1 is equal to 0, and e to the 0 is just a number to the power of 0, which is always equal to 1. With that said, let's get into solving actual problems, actual logarithmic equations. First things first, we're asked to solve for x in this equation. 5 plus 2 ln x equals 4. Now, a lot of the times we're dealing with polynomials, quadratic equations, things like that. A lot easier to solve for. This case, we have logarithms, not so straightforward. It is, but it's not so obvious what you have to do. So let's go ahead and dive right in. 5 plus 2 ln x equals 4. Just like any problem, we want to isolate the x. Right, so first things first is we're going to subtract 5 from both sides so that these can cancel out. And 4 minus 5 is negative 1, so we get left with 2 ln x equals negative 1. Next, to get rid of that 2 next to ln x, we'll divide both sides by 2. Those cancel out, and we're left with ln x equals negative 1/2. Now, how do we get rid of that ln? What can we do? If you take a look at the fifth property over here, and let me erase it so you can see better. What do you do there? You apply e to cancel that ln out. So what we're going to do is we're going to put e to the power of ln x equals e to the power of negative 1/2. Right? We have to do that to both sides. And now those cancel out, the e and the ln. And we're left with our answer, which is x equals e to the power of negative 1/2. So again, when it comes to solving equations, it's a matter of using the rules. And we only get better using those rules by solving more problems. One last example and we're done. If we had 2 to the t equals 7 and we want to solve for it, what we can do is apply ln to both sides. Now, why would we do that? This one's not so obvious again, but go ahead and take a look at rule 3, the power rule. That exponent of t, we can now bring it down as a coefficient. So with the power rule, we now have t ln 2 equals ln 7. And to isolate that t, to have it on its by itself, we'll just divide both sides by ln 2. And that's our answer. You could leave your answer like this. But if they're asking for a number, maybe rounding to some decimal places, you can plug it into a calculator and it'll give you that t is equal to 2.81. All right, that's it. Like I said, please practice some problems on your packet and please do ask questions.